Welcome to Infrastructure as Code. After watching this video, you'll be able to explain what Infrastructure as Code is, describe the benefits of IaC, and describe the various tools of IaC. Let's discuss what we mean by Infrastructure as Code, or IaC. It provides a great way for you to describe your infrastructure in a textual format. But I'm not referring to a word processing document. We're talking about a textual file format that you can actually use to configure your systems much like code. We're talking about textual code that you could hand to an IaC tool, and that tool reads the code and then builds your servers and networks and storage, etc. Essentially, the core infrastructure elements that you need. Using these tools with this textual code means that everyone gets the same environment every time, so it's consistent and repeatable. Textual code is normally written in the YAML format, which is a very common way to write and declare IaC. So why are we discussing infrastructure as code in this course? Well, performing these system configurations manually is error-prone, not to mention time-consuming. You can use templates or commands to describe how to install and configure the system according to your needs, how much storage you want, how much processing power you want, and so on. In the early days of DevOps, configuration management systems, or CMSs, made this possible, and they predated the newer IaC tools, so they were all that you had to perform tasks with. We'll discuss CMSs in more detail later. Due to repeatable configuration, you can rapidly provision the same platform over and over again and be sure that it will be in the same state every time. Infrastructure as code tools can be either declarative or imperative. With the declarative approach, you specify the desired state of the infrastructure resources you want to provision, and then the IaC tool determines how to achieve this state. It handles dependencies and executes commands in the proper order without you having to specify the order of execution. Tools that use this approach include Terraform, Puppet, SaltStack, CloudFormation, and to some extent Ansible. The imperative approach, in contrast, requires that you define the specific order of the commands needed to achieve the desired state. It's up to you to get the dependencies correct, as the tool will execute commands in the order you specify. Tools like Chef are imperative, and to some extent Ansible can be as well. Let's take a look at how Ansible uses inventory files and var files to see how they work as an IaC tool. Here, we're using Ansible playbooks as an illustrative example, but the process is essentially the same with other IaC tools. Chef has cookbooks and recipes, Ansible has playbooks and plays. They're essentially the same thing. Inventory files have a list of servers or devices that can be in the form of IP addresses or host names. They can also specify groupings of servers like all the web servers or all the database servers. This is how Ansible knows what to operate on. There are also var files that contain the relevant variables that may be needed whenever a playbook is run on a device or group of devices. You can control how Ansible interacts with remote hosts or devices based on how you define variables. The inventory files make up the most basic building block of Ansible architecture. You must reference the inventory file when executing Ansible or Ansible playbooks. So, Ansible has this notion of a playbook that contains any number of plays. Plays contain the instructions to be carried out on each server or device. Plays can be targeted to specific groups of servers like all the web servers or all the database servers. So a playbook is a collection of reusable plays that are instructions that you give to Ansible to carry out. Ansible will read the playbook and determine which servers from the inventory that the plays are appropriate for and execute the plays on each of these servers. So you could determine that you need to set up a web server, an app server, a database server, or maybe 2 web servers and 3 app servers, or maybe even change the existing configuration of a server. Whatever you need it to do, Ansible will make all the necessary configuration changes and provision all the things you need for your infrastructure. It's also important to note that Ansible is idempotent. It will not affect a server if it's already in the desired state. This allows you to be able to reapply a playbook and not worry about installing things twice. Ansible will take care not to do that if it isn't needed. So, what are the benefits of IaC? IaC automation dramatically speeds up the process of provisioning infrastructure for development, test, and production, and for scaling or taking down production infrastructure as needed. It can even automate the provisioning of legacy infrastructure, which might otherwise be governed by time-consuming processes like requiring you to open a ticket and wait for someone to do it manually. Developers can quickly provision sandboxes and continuous integration, continuous delivery environments, and QA can quickly provide full fidelity test environments. IaC ensures that provisioning intelligence always remains with the organization. In the past, the knowledge of how to configure servers may have been known by only a few people in your organization. Once you codify this knowledge using infrastructure as code, everyone is able to provision what they need, and the fear of losing tribal knowledge through staff churn is no longer an issue. Finally, IaC lets organizations take maximum advantage of cloud computing's consumption-based cost structure. It reduces the time, effort, and specialized skills required to provision and scale infrastructure. It also enables developers to spend less time on plumbing and more time on mission-critical software solutions. Now let's briefly discuss some of the main IaC tools available. Terraform is an IaC tool by HashiCorp that is free and open source. It uses a declarative approach to IaC with a pre-execution check to ensure that it will do what you expect it to do. You can use Terraform as a base tool in combination with Ansible, where Terraform provisions the base infrastructure and Ansible configures the software on top of it. It's a very popular tool for cloud provisioning. Ansible is an open source tool that automates IT tools such as intra-service orchestration, application deployment, cloud provisioning, and more. It uses familiar YAML files to describe the state that you want to achieve. Ansible is simple to set up because it doesn't require any client-side agents or bespoke security infrastructure, and it works simply by delivering modules to the clients. This makes it ideal for memory-constrained environments like configuring Internet of Things devices. These modules are run on the client side, and the results are sent back to the Ansible server. Chef describes the necessary steps to reach a final state rather than describing the state itself. Using cookbooks, you can describe various processes by which you can configure a system to achieve the desired state. One of the strengths of Chef is that it's a popular tool and has lots of support, but one of the drawbacks is that its cookbooks are written in Ruby, so you need to have Ruby skills on your team. With Puppet, you could use any existing platform. The main difference between Puppet and Chef is that Puppet is declarative, which some consider to be a preferred method. SaltStack's remote execution capabilities allow administrators to run commands on various machines in parallel with a flexible targeting system. SaltStack is designed to allow users to explicitly target and issue commands to multiple machines directly. In this video, you learned that configuration management systems were really the only tools available to configure infrastructure systems before IaC Tools became available. IaC Tools can dramatically speed up the process of provisioning your development environment's infrastructure, and there are several different flavors of IaC Tools available.